Hey everyone, today we are going to solve the LeetCode question palindrome linked list. Okay, let me explain with this example 1, 2, 2, 1. This is a true case. And we have actually follow-up question like could you do it in on time and on space? But I think it's a good idea to have multiple solutions for your interview, even if we don't meet follow-up question. So let me explain two ways to solve this question. And the first solution doesn't meet follow-up question. And first of all, intuition is if we compare like from left side and right side, from right side at the same time, we can easily find a palindrome, right? Like 1 and 1, so they are same. So move next and move next, and then we find 2 from left side and also found 2 from right side, and they are same. That's why this linked list is palindrome, so return true. But the problem is we can easily move from left to right, but it's hard to move from right to left. That's the problem. This is my intuition, thought process. Since a singly linked list can only be traversed in one direction, we can't easily access elements from both ends. So as I told you, if we compare from left and from right at the same time, we can easily find the palindrome, right? So that's why I thought I want to use like 2 pointers. To do that, first of all, copy all values into array where we can access any element by index. So since we copy all values into array, so this solution becomes very straightforward, right? Just use 2 pointers, one starting at the beginning and one at the end, and move them towards the center while comparing the value. So this is an actual algorithm. So let me show you how. Okay, let's try this example. So as I told you, first of all, we want to use 2 pointer. To do that, we convert this input linked list into array. And in this case, 1, 2, 2, 1. And then create a left pointer starting from index 0 and a right pointer starting from the last index, and compare one by one. So left pointer pointing 1 and the right pointer pointing 1. Looks good. In the case, move left pointer to next and the right pointer move next. And then compare 2 and 2. So they are same. Looks good. And move left pointer to next and move right pointer to next. So we now left pointer is greater than right pointer, so we stop iteration. All we have to do is just return true in this case. Yeah, so that is a basic idea to solve this question. So let's jump into the code. Okay, let's write the code. First of all, create an array. This is empty. And first of all, let's copy all values into array. So while head and array.append and head.var. And then after that, head pointer move next, head and head.next. And after that, create 2 pointers, left equal 0 and right equal length of array minus 1. And then let's compare from left side and right side. So while left is less than right. In the case, we continue. If array left is not equal array and right. In the case, return false. If not the case, move left pointer to next and move right pointer to next. In this case, minus equal 1, because right pointer starting from like a last index, right? And then after that, return true. Yeah, so let me submit it. Yeah, it looks good. And the time complexity of this solution should be order of n, where n is a number of elements in the input linked list. And the space also order of n because we use array to use 2 pointers. Okay, so let's talk about the second solution. So that is on time and on space. Okay, my intuition of the second solution is that if we can reverse the second half of the linked list, we can use 2 pointer technique, just like in array-based solution, solution 1. So this is my thought process. Okay, the second solution has 3 steps. One is find the middle of the linked list. To reverse the second half of the linked list, we need to find the middle point, right? So that's why first step is find the middle of linked list. And the second step is reverse the second half of the linked list. So we want to use 2 pointers for linked list. So that's why we need to reverse the second half of the linked list. And then step 3, compare values from both ends moving inwards. So we check one by one from left side and the right side. And then if they are same, we move next. And then compare again, like a solution 1. Let me explain one by one. Okay, let me explain the first step, find the middle of linked list. So question is, how can we find the middle of linked list? In this case, 3. So to do that, we use 2 pointers from the beginning. So one is a slow pointer and the other is fast pointer. And the slow pointer move once every time and the fast pointer move twice every time. So fast pointer move twice as fast as slow pointer. So that means when fast pointer reach end of linked list, slow pointer should be middle of linked list, right? So let's see how it works. First of all, slow pointer move once and the fast pointer move twice. And now fast pointer is not the last node, right? So let's continue. So slow pointer move once and the fast pointer move twice, 1, 2. So now fast pointer reached end of linked list. So look at the slow pointer. So slow pointer pointing 3. So that is a middle of linked list, right? Okay, let's talk about the second step, reverse the second half of the list. And this is the second half of the list, and this is a slow pointer and pointing middle node 3. And we need to reverse the second half of the linked list. And this is actually exact same as reverse linked list problem. And I have actually video, and I put the link in the description below, so you can check later. So I don't talk about the detail, but first of all, create a node, and that is null, and initialized with null, so null. And try to this pointer to like this, and like this. So first of all, keep next node from slow pointer. So that is 2, right? So let's say temp is now node 2. And then after that, slow.next is now 2, right? But we want to create like this, right? So that's why slow.next should be null. So that we can eliminate this link. And now link is toward to null. And then after that, so let's say this is just node. And update node with slow pointer. So that means node 3. And then, so actually there is a problem. There's no link toward 2, but no problem. So first step, do you remember first step? So we have node 2. So that's why update slow pointer with this temp, so that slow pointer move node 2 without a link. And we repeat this process. So let me show you how quickly. And first of all, we keep next node, that is 1, right? And then update slow pointer dot next. That means we reverse the link from this link to this link. So now slow.next is 3. And after that, update node to slow pointer 2. And then after that, update slow pointer with temp, so that the slow pointer is now 1. And then again, we create a no. And then we repeat the same process again. So first of all, keep next node. So that is null, right? And then after that, throw.next, update throw.next with node, so that we can create this link. And then update node with throw pointer, and update throw pointer with temp, that is null. And now throw pointer is null, so we stop iteration and look at this linked list. So we successfully reverse second half of linked list, right? So this is a second step. Okay, let's talk about step 3, compare values from both ends moving inward. So in the second step, we successfully reverse the second half of linked list like this. And all we have to do is just traverse from beginning and from end at the same time and compare each node one by one. And to use original linked list, I mean, starting from the beginning, we use head. And do you remember original linked list? So that is like 1, 2, 3, 2, and 1. And let's say we use first pointer, and this is a second pointer. And let's traverse one by one. And when we traverse the nodes, we use second pointer for condition, because definitely second half is shorter than first node, because this is the original node. And so look at these two. Definitely second half is shorter than original node, right? So that's why we use second pointer for while condition. And if second pointer is null, we stop. And first of all, check first node 1 and second node 1. So they are same, right? So just move first node, first pointer to next, and move second pointer to next. And compare 2 and 2, looks good. And move next and move next. And compare 3 and 3, looks good. And then move next and move next. So now second pointer pointing null, so we stop iteration. What is that? Software update. So now we traverse all nodes in the second half of the linked list. So we compare like a first half and second half. So that's why in this case we should return true. That is a basic idea to solve this question. So let's jump into the code. Okay, let's write the code. First of all, create a throw pointer with head and a first pointer with head. And this is a first step. And try to find the middle of linked list. So while first is not null and first.next is not null, in the case first pointer move twice, so first.next.next, and the throw pointer move once, so throw.next. And after that, step 2 is reverse the linked second half of linked list. So node equal none, and while throw is not null, we continue. First of all, keep next node with temp, so throw.next, and update throw.next with node, and update node with throw pointer, and update throw pointer with temp. So this is a second step. And the third step is compare from beginning and from the end. So first and second. So first pointer should be head, and second pointer should be node. Do you remember? And then, so we use second pointer. And first of all, first dot var is not equal second dot var. In the case, return false. And after that, first should be first.next, and the second equal second.next, and then return true. Yeah, let me submit it. Okay, let's write the code. First of all, create a throw pointer with head and a fast pointer with head. And this is a step 1. So try to find the middle node of the linked list. So while fast and fast.next. In the case, we continue. So fast equal fast.next.next, and the throw should be throw.next. So this is a first step. And the second step is to reverse the second half of the linked list. So node equal none, and then while throw, so we continue. So first of all, keep next node, so temp equal throw.next, and after that, update throw.next with node, and then update node with throw pointer, and update throw pointer with temp. So this is our second step. And now we successfully reverse the second half of the linked list. So let's create a first pointer and a second pointer. So first pointer should be head, and the second pointer should be node. Do you remember? And then let's iterate through one by one from the beginning and from the end. So we use second pointer because the second half is definitely shorter than first pointer, original linked list. So I mean half length of second half linked list should be half of original linked list, right? So that's why definitely second half is shorter than like original linked list, first. So that's why we use second pointer here. And then if first.var is not equal second.var, in that case, immediately return false. If not the case, update first pointer with first.next, and the second pointer should be second.next. And after that, just return true. Yeah, so let me submit it. Yeah, that's good. And the time is ON and the space is O1. Yeah, so that's all I have for you today. Please support me with the actions such as comment and hitting like button. I'll see you in the next question.